Pencast number 6, problem set number 6, homework question number 3. We have two dipoles that are in a, those should be negatives, dang it, negatives. They're in a constant electric field. And both of them make the same angle theta with respect to the horizontal, assuming that they have the same dipole moment, which they do. Well, we're assuming they do. Thus, these two dipoles are also parallel with each other. And the energy from them is just the energy from both the dipoles plus the energy between them. U1 can be written as the dipole moment dotted with the electric field, which is going to be PE cosine of 90 minus theta. It's going to be 90 minus theta because if we look at the dipole coming out of it, the dipole, oops, and then we have the electric field lines, and then we get the 90 minus theta part, whatever. So then, since cosine 90 minus theta is same thing as sine of theta, we'll write it like that. U2 is the exact same thing since electric field's the same and dipole's the same. And then between the two, it can be found to be U0 over 4 pi r cubed 3 the dipole, sorry, this is 1 over 4 pi epsilon naught r cubed. I was looking at the wrong problem. 3p1 dotted with e hat, p2 dotted with e hat, minus p1 dotted with p2, which is going to give us, oh, there's a negative sign in front of this, negative 1 over 4 pi epsilon naught. These are distance d apart. 3, and then each of these are the same, so we're going to have p times p is p squared. E hat just gives us a magnitude of 1, and then the angle between d and e is just that theta. Cosine of theta squared minus, and then p1 dotted with p2 is p squared. We could do cosine of 0 also, but that's not going to matter. So then the total thing is all those added together. These also have negatives in front of them. I forgot to put that in. Oh, dang it. When we put those together, we get negative 2 PE sine theta. Then we have minus 3p squared cosine squared theta over 4 pi epsilon naught d minus p plus p squared over 4 pi. Oh crap, that's d cubed. Epsilon naught d cubed. Part B, find the situation where this is maximized or minimized. I don't remember what it says. Minimized. Find the configuration in which it's minimized. Take the derivative with respect to theta. This part we get a cosine theta. And then from the derivative of this, we get a 2 out front. So 3p squared cosine theta, all from chain rule. And then we have to take the derivative of the cosine part. He's okay. Of the cosine part gives us sine theta. We need to find this equals 0. Cosines cancel. So then 3p squared over 4 pi epsilon naught d cubed sine theta equals 2pe. one of the p's will cancel. Sine theta is so crap, that's supposed to be a 2. I have to make that a 2. Okay. So then sine theta, we got 4 pi epsilon naught d cubed e over 3 dipole moment. And then we'll find that this is minimized when theta is equal to the inverse sine of 4 pi epsilon naught d cubed e over 3p. And then last, as e goes to 0, then our dipoles will want to go into equilibrium, which means they'll be facing each other. And the angle between them will then be 0. So, or between, I can't speak. Theta 0 anyway. So then u equals negative 2, p, e is 0, sine of 0 is 0, minus 3p squared, cosine squared of 0 is 1, 4 pi epsilon naught d cubed, plus p squared over 4 pi epsilon naught d cubed. These things are the same thing, which is what the constant is a negative 3 constant that has 1. Therefore, you put them together and you get negative, I'll have a negative 2 over 4, so negative 1 over 2. So we have negative p squared over 2 pi epsilon naught d cubed. And that's the energy.